So I'm very pleased to welcome Lynn and all of you to the 198th Eath2Class workshop. This was originally a program we were going to have back in February, but unfortunately I had a medical emergency and was not available at the time. As we all know, one of the simplest yet most complex equations is Einstein's E equals mc squared. Einstein figured out that energy could be made from matter, which led to the development of the first atomic bomb during World War II. During the 1930s and especially the 1940s, teams from many universities in the United States, Canada, and Europe worked together towards constructing an atomic bomb that would be much more powerful than conventional weapons. One code name was the Manhattan Project and was centered in Pupin Hall on Columbia's Morningside campus, which many of us know. But there were other locations for the Morningside Project. Not certain how well this image comes through, but has places like Oak Ridge, Los Alamos, Richland, the Berkeley Radiation Lab, Alamogordo, and many other places. The result of that work was the first successful explosion of a nuclear weapon, which was called the Trinity Test. And it took place on the 16th of July, 1945 in New Mexico. Less than a month later, two bombs nicknamed Little Boy and Fat Man were dropped on Hiroshima and Nagasaki. These are the famous images of the cloud that resulted from the explosions over Hiroshima and Nagasaki. And this image on the right shows the damage to Hiroshima 2 months after the bombing. The plane that dropped the bomb, the first bomb, was called Enola Gay, named after the mother of the pilot, Paul Tibbets. And the Enola Gay is now located in the Udvar-Hazy Center of the National Air and Space Museum near Dulles Airport. Let me give you a brief history of the USSR nuclear history. The Soviet atomic bomb project was a classified research and development program authorized by Stalin in the Soviet Union to develop nuclear weapons. There were preliminary studies in the 1930s and efforts multiplied during World War II. At the same time, the German and British scientists, as well as the Manhattan Project, were all working towards this. Stalin demanded even more after the bombs were dropped on Hiroshima and Nagasaki and ordered his troops to capture German researchers. Soviet scientists and spies obtained much information from published research papers as well as clandestine methods. In 1949, the USSR exploded its first atomic bomb at the STS Semipalatinsk test site in Kazakhstan. This is pre-Borat. Between 1949 and 1989, the USSR conducted 457 tests, many in the open air. The effects of radiation were not recognized until after STS closed in 1991. But one of the effects was that many of us who were around in the 1950s have a lot of cesium-90 in our bodies. At least I think that's the isotope. The USSR, Russia, Great Britain, France, and China are nuclear nations. Israel probably has nuclear weapons but refuses to admit it. South Africa disassembled its nuclear weapons after joining the Non-Proliferation Treaty. And the former Soviet Socialist republics, Belarus, Kazakhstan, and Ukraine, returned their nuclear weapons to Russia after the end of the USSR. India, Pakistan, and North Korea also possess nuclear weapons. The key to most agreements between nations has been in Russian, the rhyming doviye, no proviye, which means trust but verify. an expression that's very popular with President Ronald Reagan. But how do we do that when it comes to secret nuclear testing? I opened the link earlier. I'm not certain why it's having a problem now. This is an article in EOS, the AGU journal, which talks about the Soviet seismic networks. So I'll skip that for the moment and briefly talk about some of the selected nuclear weapons treaties. Treaties are formal legal agreements between nations. Most of us as scientists don't spend too much time thinking about treaties. But treaties take years of negotiation and are very carefully wordsmithed. First one, I believe, was the Nuclear Test Ban Treaty in 1963, signed by President Kennedy. And then in 1970, the Treaty on the Non-Proliferation of Nuclear Weapons, NPT, was enforced with 191 states. North Korea announced its withdrawal in 2003. Treaty on the Proliferation of Nuclear Weapons, I'll change that typo later, went into effect in 2017. And it bans the possession, development, testing, deployment, and transfer of nuclear weapons under international law. And the Comprehensive Nuclear Test Ban Treaty of 1996 has a number of nations which are signatories. There's also something called a Conference on Disarmament, recognized by the Special Session on Disarmament of the United Nations General Assembly, single multilateral disarmament negotiating forum of the international community. And it succeeded other negotiating fora. So I'm going to stop this and turn it over to Lynn at this point. Lynn, are you ready?
Yes, I am. So I'll just say a few words about how did I get involved with science. And I want to just hit on 3 points. One was teachers. So they were very important to me. So I'm happy to see a number of you here today who are teachers as well as students. Another thing happened to me when I was 7 years old. And that was that my father received a letter from a colleague working in weather in Trinidad. I noticed the stamp, and that led me to collect stamps. And as a result, learn a lot about other countries and people that live in them and their governments. And then finally, when I was in the 4th grade, my Aunt Ethel sent me a chemistry set, which my mother said, "Oh, Ethel did a terrible thing. Lynn is going to either poison himself or blow up the house." So I survived both of those things. So that will now lead me into my slides, Mike.
Okay. Let me try to find them now.
So if you do want to ask questions, I can either take them in the middle or at the end. So I think that there's a way to chat and leave a question. So I'll be happy to get those from you. Start saying a few things, and Mike, when you get it, break in.
I'll get it.
Pardon?
I will get it. I'll be back in soon.
Okay.
Sorry for the technical delays, everybody.
So let me say, how did I get involved with this subject, a scary subject? When I came to Lamont as a graduate student to study seismology in 1960, seismology was becoming a subject that was well funded. It had been very poorly funded before that. And the reason was that with the interest in having a full ban on atomic testing, the biggest problem was explosions that were put off underground. So the Limited Test Ban Treaty of 1963 prohibited explosions in the atmosphere, space, and underwater, but not underground. So what happened was that the testing of weapons merely went underground. So we didn't have a full ban on atomic testing until 1992. It was in the 1990s, sorry. And in the meantime, seismologists then started working on better methods of identifying atomic testing. There was work that went on at Lamont, particularly in developing a method called MSMB. Those are two magnitudes or measures of the amplitude of seismic waves given off by either an explosion or an earthquake and recorded at many stations around the world. So what we found in the late 1960s was that explosions generated fewer very long waves that take, say, 20 seconds to go up and down, compared to the MB, that was a measure of waves that travel through the deep part of the earth and have a frequency of about 1 hertz, or a period of about 1 second. So I'll show you later on, if we can get the slides back, some examples. So this work went on at Lamont. In fact, it might have been possible to have a full test ban around 1970, but those methods didn't become part of the negotiation very quickly. So atomic testing went on of many new types of things, including having multiple warheads on missiles, a very dangerous phenomena. Are we about there?
I'm not certain. I've got it up, but it keeps showing the wrong thing.
Let me keep on talking. One of the things that I was involved in, just called the TTBT, or Threshold Test Ban Treaty. It was negotiated in 1974. I was part of the US delegation that negotiated it in Moscow. And what it did was it set an upper limit to the size of underground tests. They could be easily detected. The US wanted to have that limit set by those magnitudes, the MB that I mentioned. The Soviets didn't want that for good reasons, and that is that an explosion at the Russian test site in eastern Kazakhstan, an area of very old rocks and in which the seismic waves propagate very readily compared to Nevada, they were much larger for, say, 100 kiloton explosion, where kiloton is 1,000 tons of TNT. So the US decided we would accept the Soviets' proposal to have the limit based on yield. I came back from the negotiations with the idea in my mind that the US methods of estimating yield were flawed. That took 15 or 20 years to get that finally straightened out, with people that argued adamantly that their methodology was correct, of merely using that MB. It turned out that what happened was that the their estimates of Soviet yields were 3 times too big. And of course, that led to statements that the Soviets are cheating on the Threshold Test Ban Treaty, and therefore the US should not sign that treaty. That finally got cleared up in 1989 with the Soviet Union and the United States allowing the other to set off an explosion larger than 100 kilotons at their test site. Okay, so it looks like we're here. Mike, let's go ahead with the slides. Okay, so these are some of the things that I want to talk about. You can ask me questions about some of them. This subject is one that involves a lot of science, physics, chemistry, earth science, international affairs, political science, various engineering things. Mike has already said something about the basics of nuclear weapons, but let me just emphasize that why are they so powerful? And that is that they involve breaking up the very small nucleus of particular atoms, either plutonium or uranium 235, or at the other end with hydrogen bombs of fusing forms of hydrogen into heavier elements. Whereas ordinary chemical explosions only involve a rearrangement of the very small neutrons that are part of the atom. Here are some of the treaties that we've already started to mention. And let me say about the NPT, that is still an important treaty because it divides the countries of the world into those that have atomic weapons and those that do not, and places certain restrictions on each of them. The non-weapon states have continually been at those that have weapons to do more about limiting atomic arms. So much has been accomplished, but quite slowly. And I am proud that you're here to listen to an exceedingly frightened topic. But I think it's one, unless we deal with it, that can get well out of hand. And one of the reasons that nuclear weapons are way down now in public attention is the idea that the arms race went away with the breakup of the Soviet Union. But in fact, while the Soviet Union broke up, that the United States and Russia both continued to have lots of nuclear weapons. And one of the most frightening things is the very short response time of about 10 minutes for a country to fire its weapons, thinking that another country like Russia is firing them at us. So there have been a number of false alarms in which each side came close to launching nuclear weapons at the other. And of course, it's exceedingly frightening for India and Pakistan that are building up their atomic weapons and could destroy perhaps 500 million people in their two populous countries. And some of the other things that, if you want, I could speak about later would be North Korea, Iran. The Trump administration has gone forward with new proposals for our atomic weapons and the systems that deliver them. The next slide, Mike. Okay, so I've already talked about these things that are the ingredients of atomic weapons. Uranium-235 is a small component of ordinary uranium that can be mined. So it has to be separated from uranium-238, which takes a lot of work, which Iran has been trying to do for some time. And that's been the route in which a number of countries acquired atomic weapons, including Pakistan for the first time. Plutonium-239 is manufactured in reactors. So other countries have gone that route. The next slide. Okay, so this shows the number of weapons that various countries have since 1945. You can see the US was the first to acquire them and to acquire a lot of them, followed by Russia that continued to claim that it needed to catch up with the United States and make sure that the US would not attack them. We can see that the US reached 30,000 atomic weapons, many of them hydrogen bombs, as did Russia, even more. In many ways, I think that this is craziness that each country would develop so many, whereas China decided that it would acquire enough for what it thought was deterrence. And as a consequence, you can see at the bottom there, China and other countries besides the US and Russia have many fewer. So for that reason, China does not want to join in the present arms control negotiations between the US and Russia for decreasing their number of atomic weapons. We can see here that those numbers have gone down, but they're still in the thousands for Russia and the US. The next slide. Okay, so this shows warheads and delivery systems by various treaties between Russia and the US, going back to 1991, then 2001, a reduction with the START Treaty. I must say that these are not all nuclear warheads. These are ones that are carried by what are called strategic delivery systems, those that can carry weapons intercontinental distances. And then finally, the New START Treaty has further limited this number. This treaty will end this next January. The Trump administration has claimed that China needs to be brought into this agreement. Russia claims that they want to go ahead with an extension of the treaty and negotiations to limit the numbers further. So that's where we stand with that matter. The next slide. Here we can see over at the right-hand side some of the increases in the billions of dollars spent on nuclear weapons, particularly on their delivery systems. And the proposal that has gone forward with the Trump administration for doing this. So this is another big item of where do we go from here. The next. Okay, getting to the frightening part. The US and Russia and China both have weapons that are a little bit smaller than 1,000 kilotons. So here shows an example of one weapon, just one, hitting New York City of about 800 kilotons, which the Russians have and we have. And we can see here that compared to a simple uranium-235 or plutonium bomb that was used against Hiroshima that would affect a much smaller area, that a huge part of New York City would be totally destroyed with no survivors, and then a surrounding region in which a firestorm is likely to occur in a huge area. And of course, with the number of weapons that Russia and the United States have today, they're unlikely to launch one against the other. They're likely to send many towards the vicinity of New York City. The next. I must mention that the Bulletin of the Atomic Scientists has a famous clock in which they set at a minute or second closer to midnight. They've now set it closer, 3.5 minutes, than they ever have before. The only time it came this close to their setting this clock was with the development of hydrogen bombs in the 1950s and their deployment. The next slide. Okay, I mentioned the technique of distinguishing between underground explosions and earthquakes. The reason for this is if we wanted to detect small nuclear weapons, those even smaller than the Hiroshima bomb, we need to take into account the signals from many earthquakes that happen, in fact, every day. So this technique shows that for two nuclear explosions of about the same size, that these long period waves, called surface waves, are much larger for an earthquake, one near the Russian test site in the Arctic, and surface waves from a nearby nuclear explosion. So here we can see the surface waves are much smaller. So this is a technique that is used today and has been used since the end of atomic testing, except say for North Korea in the 21st century, to be able to make sure that neither Russia, China, the US are testing nuclear weapons. So this is something that we in the seismological community and in the policy communities can take great credit for. But this does not mean, of course, that the danger of the use of atomic weapons has decreased a lot. The next. So one thing that was set up when the Comprehensive Test Ban Treaty was being negotiated in the early 1990s and went into effect later was that seismic stations around the world and other types of stations. But of course, with the complete ban or comprehensive ban, we want to make sure that someone is not testing something small in the atmosphere or underwater or in space, as well as underground. So the countries of the world that have signed this treaty have all agreed to a huge number of stations. These stations send their recordings almost immediately to a common place in Vienna, in which they are dispersed to those countries that want them. And the US, for example, gets all the data, as I believe Russia and China do as well. So the US has gained a lot here. There are stations that didn't exist before in Mongolia, Ukraine, Kazakhstan, that border the Soviet Union, and which we had dearly wanted to have monitoring posts previously. And now we have good stations in those places. The next slide. Okay, I had mentioned that there was a big disagreement about the threshold test ban treaty. If an explosion of a given size, a given yield is set off at one of the Soviet Union test sites, and our test site, former test site, in Nevada, that there is absorbing material in the lower crust and uppermost mantle beneath Nevada that leads to a small seismic signal and one that's not as enriched in high frequencies. So we can see at the top right, the signal from a US test and one from a Soviet test, either at their Arctic test site or their former test site in Kazakhstan. So this led to this big disagreement of people in the US claiming that the Russians were cheating, and others like myself that we were not taking into account these differences between the Earth beneath the various test sites. This was finally resolved by each country setting off a large explosion in the other countries. And it confirmed that there was this absorption beneath explosions set off in Nevada compared to those beneath the Soviet Union's test site. And so people that claimed the Soviets were cheating, of course, did not want to see a full test ban. So the resolve of this question in 1989 then led to the rather quick negotiation of the full test ban. The next slide. Okay, so this is the place where the Soviets tested at this remote island, Novaya Zemlya, in the northernmost part of Russia. It's even farther north than the northernmost part of Alaska. About the time that the comprehensive test ban was being negotiated, and in fact, soon after it was signed, there were a number of claims that there were very small events, which you can see them labeled here. They were of very small magnitudes, not felt to a very large distance, but in fact, seismic stations recorded all of these, and in fact showed that they were all earthquakes and not underground explosions, even small underground explosions. The next slide. This is one of the phenomena at that northern test site in front of the officers' club. So you had to go outside with a rifle there if you went outside. The next slide. Okay, so what explosions of what yields, of how many kilotons KT are important? We can see here, this is a plot from the 1970s and 80s of the frequency of Soviet testing at either of their test sites. And we can see a huge peak at around 10 kilotons. Why is this important? Because hydrogen bombs use a plutonium or uranium-235 trigger to set off the hydrogen bombs. So it's important that those triggers be tested. And that's why there's so many here at around 10 kilotons. At that time, the threshold test ban treaty of 150 KT was in effect. And so that's why there is a peak there. And we can see once we get below about 1 kiloton, there were very few US or Soviet explosions of that size. The US developed some weapons in the 1950s and 1960s for defense of Western Europe. But the one other thing that continued to be tested, a few of them down in that size, was to test the exposure of electronics to a small nuclear explosion that would generate enough radiation, heat, etc., to test that equipment. So this is something that was not part of the development per se of atomic weapons. The next slide. Okay, let's go back to that for a minute. Is it possible to go back, Mike? Okay, so up at the top, I have listed as a function of time some of the US claims that the Soviet Union had cheated or was cheating. One graduate student and I looked at a US report that was published and claimed and submitted to the UN's Conference on Disarmament in 1972 that there were small events in Tibet and Central Asia that looked in their seismic signals like underground explosions. So we worked on that document, and the data were these MS and MB readings of the high frequency and low frequency seismic waves. And we found, lo and behold, that in the public domain, we could find 3 times as many signals. And when we did that, all of these events in Central Asia and Tibet went away in the sense that they were identified as earthquakes. Up at the top are some events near the Soviets' Arctic test site that were claimed to be explosions, and in which we showed that they were not. There was one small Soviet explosion in Ukraine and a coal mine that was a very small nuclear explosion. But that's now more than 30 years ago, and we could identify an event like that readily with the present international network. So over at the left-hand side are an indication of what can we do today. So once we get down that small, there is nothing that can be done except a physics experiment at these very small yields. So you can't develop with confidence the trigger for a hydrogen bomb. The next slide. Okay, one of the big items that Edward Teller, one of the people who was the developer of the hydrogen bomb in the United States, proposed that a country like Russia could set off an explosion in a very large cavity underground and muffle the seismic waves, and that we would not be able to detect an explosion of several hundred kilotons set off in that way. But here we can see some of the aspects that even for an explosion of a few kilotons, it takes a huge cavity. Most cavities in hard rocks or in soft rocks like sand and gravel readily collapse, at which they have done when they've been made by regular atomic explosions. The one material in which it's possible to set off an explosion in a cavity that will stand for a while is salt. I did a lot of work on this in the 1980s, published an 80-page paper called Dealing with Underground Explosions Set Off Clandestinely. So this is now regarded by the directors, at least one of the weapons directors, as not being a feasible thing, that it in fact was a political ploy to try to put off a comprehensive test ban treaty, which it managed to do from 1963 until the 1990s. The next slide. Okay, the one thing that we found, and that is that here is an explosion of about 1 kiloton, a small explosion set off in a cavity. And I'm sorry, it was a 10 kiloton explosion set off in a cavity in Western Kazakhstan by Russia. It was an atomic explosion. It just happened to be in the tail of a large earthquake, which is the signal at the top and the left-hand side at the bottom. But this is a record at the bottom that records more high frequencies. So we can see that that event in the middle of the figure at the bottom is very clear and identifiable. It's not very identifiable, if at all, at the top. The next. I might mention that in addition to scientists and political scientists, there has been some work done on the psychological aspects of the arms race. One notable person is Jerome Frank, who was previously, until he died, at Johns Hopkins University. So I recommend his book and others to you. The next. Okay, so some of the things that I can talk about, and I don't have enough time to talk about them all today. The first is deterrence. And there's been a lot of talk in the last several years about North Korea. And could North Korea deliver a weapon to the United States? There were similar discussions that went on about 1968 when China had developed its first atomic weapons. You may notice that China has enough what they think can deter an attack by the United States or Russia or any other country. And remember, North Korea has something of the order of 5 to 15 nuclear weapons, a relatively small number. The big question today that I mentioned earlier is that deterrence may fail. Even though we have reduced the number of weapons carried in intercontinental distances by Russia and the United States, something may happen in that 10 minutes that leaders have to make a decision to launch their own nuclear weapons back at a country that they think has launched weapons at them. So this false alarms and nuclear accidents are the huge problem that I see today. The idea of using ballistic missiles for defense, of knocking down incoming weapons of another country, for example, one sent by North Korea, is something that goes back many decades with many different proposals. The US has spent many billions of dollars on this, frightening Congress into believing that such a system can be developed. Ronald Reagan, its administration, was one of the big proposals of a missile defense system. I think that, and many scientists think that this is not feasible, that another country can always defeat missile defense by, in fact, building more weapons or building smarter weapons to avoid missile defense. So I think this is one thing in which the US could give up spending this amount of money on this dangerous defense or idea of having a defense, but we should be able to get China, Russia to give up something themselves. So they want to see ballistic missile defense by the US halted. So there could be room for a major agreement here in which we could gain something by limiting our ineffective ballistic missile defense. Okay, there has been increased concern about nuclear weapons in Europe and Western Russia. I won't talk more about that, but these are not weapons that were covered under the present New START treaty. They were covered by a previous agreement in which the US has gotten out of that intermediate forces agreement. So this is another subject now for political discussion and debate. Another is no first use, in which the US does not have a policy of no first use. Some other countries do. And there has been proposals that the US should resume nuclear testing. What would happen if we do is that other countries like China and Russia would very quickly resume nuclear testing, and probably other countries, India, Pakistan, etc. We have done more testing than any of them, and they will only catch up in a relative sense if they test after we have tested. And then let me say one treaty that was mentioned by Mike in the beginning is the treaty abolishing nuclear weapons. This is a new treaty that was put forth mainly by those countries that do not have nuclear weapons. They have managed to get that through the UN's group that includes them. And it has now garnered enough signatures to make that an existing treaty. But what has happened is that none of the nuclear powers have shown any interest in it at all. I think it was a mistake to put forth this treaty. Other people disagree with me on this, that we are nowhere close to any of the countries that have nuclear weapons for one of them deciding to ban their weapons and destroying them. I think we have to move in a deliberate fashion to limit many other things that can reduce the dangers of the use of nuclear weapons. Okay, and the next slide. Okay, and I've merely put forth here some of the Russian fears and the US fears of, in fact, why did we get 30-some thousand and the Russians 40-some thousand atomic weapons previously, before the numbers were reduced by treaties. Russian fears the US, Europe, and China will invade Russia, as happened many times in the past, the most recent being Germany invading Russia and the tens of millions of lives that were lost in Russia. Russian fears is the US will use its technological advantages, which it has many times, to try to become dominant in the arms race. In each one of those cases, Russia has caught up. And one of their fears is that others will attack communism and socialism. US fears Russia will cheat on arms control agreements. Russia is a cruel totalitarian regime. Putin is not a nice person. He's a dangerous person. Russia tries to get an advantage in the arms race. It's secretive. It hates capitalism. And Russia and China use electronic spying. Okay, and then the next slide. Okay, my final slide is that I have published 2 books. This first one by Columbia University Press called Silencing the Bomb, which of course is about the nuclear test ban treaties, US and international efforts on that behalf to arrive at a comprehensive treaty. And it's not, of course, an end to nuclear testing, but it's something that I am proud that we and others have been involved in a small way. So thank you very much. Thank you for coming.
Thank you very much, Lynn.
Thank you.
You're
Thank you.
welcome.
Chris, let's keep the recording going as we go through questions. Looking at the chat first. We have a question from Bob Nath. Bob, you want to say it? Mute yourself and say it.
Yes, actually, there were 2 questions I had, so I'll take advantage of this opportunity and say them both. I'd like to comment on Iran and all this, particularly in view of the fact of its published zeitgeist of wanting nuclear weapons, especially to destroy Israel. And second, I would like to hear comments on tactical nuclear weapons, which in my mind are much greater danger of being used than strategic nuclear weapons. Thank you.
The last question, we do need to remember that these tactical weapons, while they're called small today, are something like the Hiroshima bomb. So they're not things that are surgical things that can take out some electronics or some missile system, but they're going to kill a lot of people if they're used. So yes, they might be used more quickly than a weapon, a hydrogen bomb that's 100 kilotons and larger. But there's still a huge different question that if they're used, if they're launched, another country will not know whether they're small or very large. And then the other question about Iran, I think that there is no question that Iran wanted to gain nuclear weapons. And the treaty, which the main US negotiator spoke at Columbia by way of Zoom a few days ago about the prospects for renegotiating agreements with Iran. Those agreements did lead to permanent verification systems, including seismic. We can tell whether Iran has tested or will test in the future a very small nuclear weapon, much, much smaller than a kiloton. They haven't done this since the treaty was instigated or went forth. The Trump administration withdrew from that treaty. So this is a big item for debate and possible negotiation under a new administration in the US. One of the things that was not negotiated at that time was missile systems by Iran. So there certainly is room for further agreements to try and limit Iranian missiles for delivering weapons, either against other countries in the Middle East or elsewhere. Okay, thank you.
Lynn, one of the questions that I have is, with the new administration coming in, how do we get them to think about some of the things that are important in this topic?
It's difficult because I think that there are three huge things that face us as a civilization. One, of course, is the COVID-19 virus, and it's going to get worse. We will need to deal with it. Understandably, the new administration is putting a huge emphasis on that, but it's likely to go away sooner than the dangers of either climate change or nuclear weapons. Climate change has fortunately gone way up there in great public interest, congressional interest, and that of the executive in the United States and in other countries. But I think it's a mistake to think that nuclear weapons are not very important. Right now, they're way down at number 10 or smaller on items that were either discussed during the presidential debates or elsewhere or in Congress. I did notice that our senator from New York is very engaged and is giving a talk soon on this topic, along with several other people.
Thank you. Art or Klaus, do you have anything that you would like to add from your experiences?
How about any students?
I'll unmute. Lynn, thanks for that summary, and thank you for being at the forefront of not only this research, but the activism to make contributions. But one thing I've always found interesting is that despite the political differences and the list of fears that you generated, there still are agreements to share seismic data, nuclide data, hydroacoustic data, and so on from all the different countries. How stable do you think those data sharing agreements for the purposes of verification will be?
One thing that has happened several times is the idea that the US should cut its funding, reduce its funding to the agency in Vienna that's distributes the verification data to other countries. And it's been possible to reply to that idea that we should, the US should reduce its payments perhaps to zero for that, by saying that although we put in 20% of the cost of the whole system, we gain a lot. For example, with these stations in Mongolia, Russia, China, Ukraine, Kazakhstan, etc. So that has led to Congress continuing to put money into that verification agreement.
I have nothing to contribute on the big picture except a little episode. I think it was in the 90s when Japan, US, agreed that they would negotiate with North Korea to replace their Russian nuclear reactors with Western US built reactors to avoid fission products to be used for nuclear weapons development. So the State Department approached an engineering firm here in the US to help develop these new sites for Western nuclear reactors in North Korea. And they in turn approached us to make a seismic site survey to assess for these new North Korean nuclear locations, the hazard for those nuclear reactors. So we actually sent a team over to North Korea, believe it or not, and established a seismic network there. And we were very surprised that the North Koreans handed over all the data, except there was 1 day missing of data. And one day, Paul Richards, a colleague of Lynn Sykes at Lamont, came to me and said, can we have those data on a particular day? And it was exactly that day was missing, meaning they set off an underground nuclear test and they promptly switched off our seismic stations for that day, which in itself was an indication that it was a nuclear test. Since then, these negotiations have fallen apart. Japan was still very interested in going that route, but the US took a hard line towards North Korea and all these negotiations in replacing those nuclear reactors that are capable of producing weapons-grade material have fallen apart, and North Korea has gone ahead.
Thank you very much, Klaus.
I might say that with those North Korean explosions, there was no question that they could be detected by stations outside of North Korea. We didn't need the North Korean stations per se, although we would have liked to have had them. And as Klaus said, this was a quick indication that North Korea did something on that day, and it was set off a sizable nuclear explosion.
Thank you.
Am
John
I
Roeder.
on here?
Yes, Tom?
Yes, greetings from Arizona. You indicated data on the number of nuclear weapons. How do we know how many nuclear weapons the various nations have?
I am not a member of the CIA, so in this case, I have to use estimates that have been published in the US and other countries. It's not something in which I have witnessed a big disagreement about those totals. There can be disagreements about whether one country has 32,000 or 33,000, or today 2,100 or 2,150. But I think that those numbers are small compared to the totals for each country. Many countries, of course, keep the numbers that they have secret. So there are still estimates for North Korea that they could have as few as 5 or perhaps as many as 20.
Thank you.
Thank you. John Roeder, do you have any questions?
No.
Okay, thank you. We have just a couple more minutes of scheduled time. Anyone else want to jump in? Journey, you have anything?
Mike, I'd like to add just an historical note, if I may.
Please do, Mary.
I attended the University of Rochester for my studies in geology. Excuse me. And the U of R had a small cyclotron there. During the Manhattan Project years, the magnet wires, the copper, was stripped out of those magnets and sent probably to Manhattan to enhance their studies there. Tom, had you heard that story?
No, I have not.
I heard it from my dad, a metallurgist and electrical engineer. And I wished I had inquired more fully, but I thought it was an interesting story of how the U of R contributed to the war effort.
I can add to that, that's why we didn't have copper pennies in
Yes.
1943.
Yes.
And they also melted silver from Fort Knox to make electromagnets to separate the uranium isotopes. This was before they had the gaseous diffusion. They were using electromagnetic separation. And now they've torn down all the gaseous diffusion buildings in Oak Ridge, and they're using centrifuges. That's what Iran is using too.
Progress.
Bill Smith, do you have anything you'd like to question Lynn on?
Yes, I will say something, and that's about the manufacture of plutonium. And of course, it's manufactured in reactors, some of which were designed solely, like those at Hanford in Washington State, for making plutonium for bombs. The Russians, of course, did the same thing. And so there has long been a question about whether a country could clandestinely run a reactor and separate out the plutonium. And in some cases, this is covered by international agreements that allows inspections to tell whether a country is violating that. But for example, India got its first nuclear test and then tests by secretly removing plutonium from an unsafeguarded reactor or several reactors. It had some other reactors in the country that were safeguarded, but a few wasn't enough.
Thank you very much, Lynn. Okay, we're just about out of time, so any final questions?
Yeah, Mike, if you don't mind, I just wanted to ask, we've come a long way with advances in instrument technology, and I got to imagine seismographs today are much more sensitive than the ones that were built a few decades ago. With the advances in technology, would we not be able to monitor a seismic event like a test, even if we lost coverage of a large area of the globe, like let's say China or Russia pulled out of the treaty that allows us to share data?
Well, I think it doesn't matter so much for countries other than China and Russia. If they or the US withdrew, that would be a very big problem. But nonetheless, there still are important things that can be detected and identified, even with a much smaller international network. In fact, one of the things that was proposed in the 1960s was that underground testing should be included in the 1963 Limited Test Ban Treaty to make it a full ban on underground testing larger than a certain amount. And that was largely explosions that would have been of military significance. That didn't happen. one of the things that prevented that from happening was this idea of setting off significant explosions, significant militarily, in large underground cavities. It took a long time to argue against that.
Thank you. Any other questions? If not, I want to thank Lynn Sykes.
You're welcome. I can see the claps.
We're getting good at this Zoom stuff. Okay,